I say there. Hello, chaps and chappies. Wheezenkopf's the name, Professor Wheezenkopf. I'd like to talk to you today a bit about the Earth. Isn't that neat out there? I bet you wish that you were there. Just look at all that marshland. If you could see a little farther out, you would see the ocean. But if you look around where you are, you might see either a classroom, or outside you might see some trees, some grass, some soil, buildings, things like that. But if we could see what is a few meters underground below us, we would see the same thing whether they're on the marsh or they're where you are. Every day we walk or drive around some part of the Earth's surface and we see what is sticking up. But what can't we see? We know that subways run underground. We know that our water wells get water from underground. We know there's sewer systems and gas lines underground. But what do we really know about what is under our feet? Probably very little. Fortunately, scientists have been studying the structure of the Earth, and we can learn a lot about by studying what they have discovered. Now, scientists have studied the internal or inside structure of the Earth for hundreds of years. The problem that these scientists have been faced with is that they cannot make direct observations. They can't exactly go down and walk around. Still, they have gathered lots of information, they've analyzed the data, and they've come up with theories about what the Earth's interior is like. Over the years, these scientists have sometimes changed their ideas, their theories, and even rewritten their books because of newly discovered information. Now, just how have these scientists collected information about something they can't see? The two main ways they have collected information is by drilling into the Earth and by using seismic information. The first method they use involves drilling into the Earth. They can bring out sections of the Earth from holes as deep as 8 kilometers into the Earth. Now, a kilometer is a little over a half mile, so 8 kilometers would be about 5 miles. Imagine drilling a hole that is 5 miles deep. The problem with drilling into the Earth is it is 6,370 kilometers deep. Now, another way they've collected data is by using seismographic equipment. These tools measure the seismic or shock waves produced by earthquakes. Now, by analyzing this data, scientists have gained valuable insight into the structure of our planet. But back to drilling for just a moment. On Russia's Kola Peninsula, near the Norwegian border, at an latitude about the same as your Prudhoe Bay, Alaska on the Arctic Ocean, they've been drilling a well since 1970. It is now over 12 kilometers, or about 7 miles deep. The previous deepest well was actually a gas well in near Oklahoma, but it was only a little 6 miles deep when they struck molten sulfur. Now, once information is collected and the data is analyzed, the theories are developed. From these theories, scientists are able to create models. Just as the theories may change when new information is learned, these models may also change. Now, today, scientists believe that the Earth is made up of 4 layers. The crust, which is the crunchy outer part, the mantle, which is the largest part of the Earth, and this is where volcanic lava comes from, the outer core, which is molten iron and nickel, and the inner core, which we believe to be solid iron and nickel. Using this model, scientists have been able to explain the many geological events such as earthquakes and volcanoes, and something about the movement of the continents. With these models, scientists hope to develop a better understanding about the past of our planet and maybe even predict things such as earthquakes and volcanoes. Remember, you discussed something called uniformitarianism that says whatever's happening today is probably what happened in the past. The Earth's crust. I want you to think a moment of an egg and its parts. The yolk is the center, then there's the white of the egg, which is surrounded by a thin shell. The Earth can be compared to an egg. It also has 3 major parts. The core is the center, then there's the mantle, and then this is all surrounded by the crust. As far as scientists know, all life exists within, either on the surface or within just a few meters of the surface. Just like our egg, the outer layer of the Earth is hard and crunchy and is called the crust. We live on the crust, and this is where all of our water, our lakes, our oceans, oil wells, coal mines, everything we use comes from the crust. Remember, we've never been able to dig through the crust. The crust is made up of different kinds of rocks, But the two main types of rocks are granite and basalt. Basalt is much stronger than granite. The upper or continental crust, though, is made primarily of granite covered by sedimentary rocks. You remember what sedimentary rocks are, don't you? Well, beneath the granite we find basalt. Basalt makes the bottom of the crust. Ocean crust is made only of basalt. Since ocean crust is thinner, it has to be much stronger than continental crust. Scientists do believe, though, that the ocean floor may be covered by a layer of sediment as much as 1/2 mile thick. Scientists refer to this crust as the lithosphere, the crunchy solid portion of the earth. The word litho comes from a Greek word which means rock or stone. Now, scientists believe that this lithosphere is broken into several giant segments called plates. They also believe that these plates move or drift about on the hot molten material that is just below the crust. The lithosphere, or outer layer of the Earth's surface, can be divided into two kinds of crust. Remember that: continental crust and ocean crust. Thick continental, thin ocean. Now, as you might expect, continental crust is found under the landforms or continents, and it is thicker. Continental crust is usually about 35 kilometers thick, but it may be as much as 70 to 75 kilometers thick, depending upon where you find it. Now, where would you expect to find this thicker crust? Under the mountains, of course. Now, continental crust is made up of granite. Granite is a light-colored igneous rock. I know I'm repeating this, but I want you to remember. Also, remember I told you that oceanic crust is much thinner than continental crust? Well, oceanic crust may be only 5 to 7 kilometers thick. But remember also, it's made of basalt, which is much stronger. The mantle. It's egg time again. Remember, the eggshell is the crust, so what we see next is the next part of the egg represents the mantle. Whenever we peel an egg, the shell is actually stuck to a very thin layer of plastic-like stuff. Well, the Earth has a very thin boundary or layer between the crust and the mantle called the Mohorovičić discontinuity, or the MOHO for short. We'll call it the MOHO. The MOHO is sort of like a fence or a barrier between the crust and the mantle. Speaking of the mantle, it is the second layer of the Earth, going from the top down. The mantle makes up 80% of the Earth's total volume, about 68% of its mass. It is definitely the heaviest part of the Earth. The mantle appears to be composed of silicon, oxygen, aluminum, iron, and magnesium. There seem to be, though, greater percentages of iron the deeper we go. The deeper, the denser, the more iron. Now, scientists have developed a model of the mantle which says that the first 100 kilometers is very rigid rock. From that point to a depth of about 250 kilometers, they believe the mantle is close to its melting point. The rock has reached a sort of gooiness. It hasn't changed totally from a solid to a liquid, but it's kind of like thick syrup or melted chocolate. It doesn't actually melt because of the extreme pressure exerted upon it. Okay? As you go deeper into the mantle, the temperature gets hotter. At the top, it's about 870 degrees Celsius, but down near the bottom, it's nearly 2200 degrees Celsius. Now we get to the core. The center of the Earth is like the yolk of the egg, with the exception that scientists believe that there's actually two layers of the core, an outer core and an inner core. The outer core is believed to be about 2,250 kilometers thick. The temperature goes from about 2,200 degrees Celsius on the upper edge, and it gets as hot as 5,000 degrees Celsius down near the bottom. Scientists believe that this outer core is liquid, very dense melted iron and nickel. This dense iron core is believed to help cause the Earth's magnetic field. Now, the inner core is believed to be about 1,300 kilometers in depth. Temperatures are believed to be about 5,000 degrees Celsius throughout the entire inner core. They also believe that the inner core is solid iron and nickel. It's solid because of the incredible pressure on it. This pressure is as much as 2 million times stronger than the pressure on the surface of the Earth. Now, we've discussed a lot today. I want you to think about the Earth having its 4 layers, that it's over 4,000 miles to the center, and that it's over 5,000 degrees Celsius. But hang on to your hard hats, because the really strange part is yet to come. Wait till we learn about plate tectonics.